Hi, this is Steve Withers at CES 2011 in Las Vegas, and it's with great pleasure that I'm joined now by Laurie Fincham from THX to discuss some fascinating new technology that has been developed here, which I think is designed to address a certain number of factors. But let's start with the problem with the sweet spot, Laurie.
A sweet spot used to be a very small one just in front of you. And what's happened is families have become more social. Now they want to sit anywhere. So what we've done is to create a technology that wherever you sit, we can bring the music to you.
So basically it's addressing the fact that as the television becomes the centre of someone's home, everyone's sitting there and only in the old way, basically the middle sweet spot would only get the best sound, and everyone else was basically getting a compromise, effectively.
It's partly that, and it's partly the fact you don't want necessarily to listen to what somebody else is listening to. So with this, you're able to do that. We can direct these sound beams towards you. You can have it, not have it. It can be different things, different programs. You can sort of have what you want. It's sort of ultimate selfish experience, but without upsetting other people.
Okay, so I guess the first question is, how do you achieve this then?
Basically, it's about steering sound, and we've known about that for some time. There have been obstacles to it. If you want to steer sound, you have to have a perfect source. Normally, they're either too big or too small, and we've come up with a way of doing that by taking a round source like this and turning it into a narrow slot. We don't lose anything on the sound. What we do is do three things, essentially. We can make it smaller. We can change the packaging and design options, and probably more importantly, we control the way the sound comes out. So let's say we had a slot like this, for example. Supposing this was a series of slots. What you know from this, these individual elements here are omnidirectional in this way. This way, they're the same sound because they're small. In this way, the directionality now depends on essentially a couple of things. How long the line is, what the spacing is, and so forth. The longer you make the line, the lower frequency you can direct the sound. The closer together you make them, then the higher frequency you can go to. This particular line will steer from about 120 hertz up to 18 or 20, but you could make it go higher or lower. The important thing here is that you can do what you want. So this one allows you to do this, for example. You can take the beam, and you can make it narrow, you can make it wider at will. I can take the beam, I can point it at this person, this person, this person, or this person, and this person, and this person, or not this person. So whatever you want to do is just fine. Granny's in the corner. She doesn't want to hear what you're hearing. She doesn't have to. So we can swing it right the way over to there, right the way over to the other side. I think the most difficult thing we had to solve with this was amplification. Amplifiers are big, heavy. The good ones are anyway, and they give out a lot of heat. So we came up with a brand new amplifier, essentially, which is analog. Analog's absolutely fine, but we overcame the limitations of analog by making one with a tracking supply such that when it's doing nothing, it takes nothing. So it probably has one of the lowest standing dissipations of any amplifier on the market, but when it's running at full level, we use tracking power supply and other circuit techniques, and we have a patent pending on this. And you can see for yourself how it's done, but essentially it matches the demand of the program, the amplifier to the demand of the program. In the same way, we're trying to match the music delivery to the demands of the customer. So it's not about us pushing something to them, it's about us giving them what they want. It's instant, it's now, and it's simple.
Okay, I guess so that's the amplification and the speaker array. How is it all controlled?
Well, basically the system that we use is we run all the software with straightforward PC software, but it is a network system. So if we look at this board here, for example, can we look at this board? It'll be all right. Okay. This is one of the boards within this particular system. It's got 92 channels. This is one board which has 24, and we use 23 of them. What you see on this is each one of these represents an output stage. The 24 of those, each one of these is a tracking supply. That whole board there will give out a peak output. By peak, I mean as long as any program would require. It's not about sine waves, it's about program. And so this board actually can deliver 2400 watts, and there are 4 of these in the system. The interesting thing about it is that all the components here are very simple. There are no electric capacitors, there are no inductors, so it's very thin. 3 millimeters. Again, it's about packaging, but the most important thing is it runs cool as a cucumber, which means we don't need big heat sinks, and you can put it in a rack and so forth. So it's supposed to be what people want. These are all linked together. We're using what they call the audio-video bridge, which is it's not that recent a protocol, but essentially it allows you to bring a number of signal channels in, could be 8, and you can link these together. So you can add another one, and another one, exactly the same way as you'd add a PC. It's a two-way communication. You can send audio and video down it. The audio and video can be precisely synchronized, not just approximately. The line array depends on the synchronization within 1 microsecond to get some of the steering, and we can do that within the software. You can monitor what's going on. Each device has its own address, so you know what it is, you know what it's doing, and you can feed its EQ. So it's an ultimate building block. Like I say, we've invented the brick. You're an architect or a builder, build what you like, but you'll know in advance what it'll do. So it's a standard building block. So sweet spot for anyone, everywhere, simple ideas, slot, amplifier and control, and upgradable through the network.
And could there be a possibility of, when you're sat in a sofa like this, sit there and happily control it with maybe a remote or perhaps an iPod?
Oh, yeah, you could do that easily. You could have it track you if you wanted to. You could have it like you'd have something turning the light. Anything you can think of with lights, moods and settings you can do with it. So now you light up a room in the same way that light up a room with sound in the same way that you do with lights. You want to read and so forth. So it's intended to be the way we live and work rather than the way technologists say you should do it this way. I don't even see this speaker. It's not important. I want to hear it. That's what I usually do. I want to see the picture, but I don't want to see the speaker.
That's absolutely fascinating. It's an interesting way of addressing the way modern life is now, with everyone centering around the television, but not necessarily wanting to do the same thing or listen to the same thing. Or, yeah, thank you very much, Laurie. That's fascinating.
Thanks. Bye-bye.